Okay guys, I'm going to get you going on the warm-up here. Let's look at this warm-up the way that we looked at our equations the other day for our word problems, deciding if I should be in standard form or if I should be in slope-intercept, because I'm given two totals here, $1.55 total and 11 coins total. I know I'm going to be in standard. So I'm going to take those two totals. One of them is 11, one of them is $1.55. Then I somehow need to get my variables involved here. My variables are just the number of nickels I'm looking for and the number of quarters I'm looking for. So let me write that up here. N will be the number of nickels, and Q will be the number of quarters. Okay, so I know that the number of nickels plus the number of quarters just has to give me my 11 total. But for the dollar amount, I need to include the value of these things. So I know that each nickel is worth 5 cents, or $0.05. So I'm going to have 0.05N plus 0.25Q, and that will give me my $1.55. Why don't you go ahead and pause the video right now, and we'll see if you can come up with the solution for that. Okay, so what I would need to do is I could either approach this with elimination or with substitution. I'm going to approach it with substitution. I know that I can rewrite my top equation solved for either n or q. It doesn't really matter here, I'll solve it for n. So I know that n is going to be 11 minus q. So I'm going to take that and sub it in for n in my second equation. So I'm going to get, when I do that, 0.05 times 11 minus q plus 0.25 q equals $1.55. Okay, after I clean all of that up and I solve for q, I'm going to get that q comes out to be 5. Once I know that q is 5, I know my total added together has to be 11. So if q is 5, I know that n plus 5 has to be 11. Therefore, n is 6. So I have 5 quarters and 6 nickels. Okay, so moving on, why don't you guys go ahead and write down the target for today at the top of your notes. Our target is to explain and justify the number of solutions for any linear system of equations. Now you might think we've already done that, looking at 3 different ways to solve systems of equations, but there are some cases that we have not looked at yet. Specifically, all of our systems have had one solution, or if you look at it graphically, they have one point of intersection. Now, there are other cases that can happen when I graph two lines, and we kind of alluded to this a few days ago, but if I graph any two given lines, I don't need a guarantee that I have one solution. They may not cross in one point, or it's possible that they cross in more than one point. That's what we'll look at today. So let's take a look at these first examples here. I'm just going to work through one of these, and then we'll have you guys try the other one. I want to graph both of the lines in the system and see if they have one solution or potentially some other case. This first example tells me that I should have no solution, and we'll see why that is. So what I'm going to do is rewrite both of these equations in slope-intercept form. So you guys can go ahead and do that. But I'm going to solve for y on my top one. If I go ahead and do that, I get y equals, I'm going to subtract the 3x to the other side and then divide by 2. So negative 3 over 2x, and then that 10 divided by 2 will be a plus 5. On my second equation, I'm going to do the same thing. I'm going to subtract that 3x over. So when I do that, I'm going to have negative 3x on the right-hand side, divide by 2. I have negative 3 over 2x, but now that 2 is going to get divided by 2 and give me a plus 1. So when I graph both of these lines, let me graph the first one here. I'm going to start up 5. 1, 2, 3, 4, 5. Right here, about. And then I'm going to go down 3 over 2 to graph. So down 3 over 2 might get me about right there. And then I can do that a couple more times just to get a decent picture. Down 3 over 2 again. So my line is going to look something like this. Okay, now I'm going to graph my other one. I'm going to start up 1 and then go down 3 over 2. But when I do that, you may notice that these two lines have the same rate of change. So if they have the same rate of change, they're never going to get closer or further apart from one another. So these two lines will never cross. These two are parallel, which tells me that they will never intersect, thus they have no solution to the system. There's no point that exists on both of those lines simultaneously. Okay, so I'd encourage you to go ahead and try number 2 and see what happens there. We're supposedly supposed to get infinitely many solutions. So why don't you take the same approach and solve my top equation here for y and graph that on the same graph that you're going to graph the second one on there. And let's see what happens. So you can pause and go ahead and try that. Okay. What we should have seen is that we have the same line. So they were right on top of each other, meaning that they have every point in common, infinitely many points in common. So we can kind of take an approach here to categorize some of these things. I could graph 2 lines and I could get no solutions. That's if I have the same slope, but I have a different y-intercept for the lines. So different b value, y-intercept. I could have infinitely many solutions, so they have every point in common. That's if they have the same slope, but at the same time they have the same y-intercept. That just means they're the same line. They're sitting right on top of each other. And then the old case that we were doing, I could also get one solution back. That's just if they have different slopes. Okay. Now you might be thinking, well, what does the y-intercept have anything to do with that case? I encourage you to think about that. If they have different slopes, for example, y equals 2/3 x, and then y equals 4x, but then let's say they have the same y-intercept, +1, +1, think about where those two lines might cross, what the solution to that would be. You can go ahead and graph it if you need to see that, but there is kind of a shortcut there that you might be able to spot. So we can use these 3 different categories for number of solutions of a system to kind of guess what's going to happen with this system before we actually solve it. These are the only 3 cases that can happen. So I can either have 0 solutions, I could have infinitely many solutions, or I could have 1 solution. There's no way I'm going to get a system of equations, linear equations, that has 2 solutions. It's just not possible. If I have a line, it's not possible that I have a line that crosses it once and then comes back and crosses it again. That cannot happen. So these are the only cases: 0, infinitely many, or 1. So let's look at the next set of examples. I don't want to solve these. I just want to use those categories to determine which of those situations might arise. So we're going to solve each of these equations for y. I'm going to do the first example here. If I solve each of these for y, my first one comes out to be negative 5x minus 2. If I solve my second equation for y, I want to add 10x to the other side. So I'd have negative 2y is 10x plus 4, and then I would have to divide by negative 2. So what I get is y equals negative 5x minus 2. Now, if you notice, these two lines are exactly the same. Because those are the same lines, same line, same slope, same y-intercept, same set of lines, we have infinitely many solutions to this system. You can go ahead and try the next one and see what might happen there. Okay, really the last thing we need to look at here, like any good math lesson, is to have an application problem, so how these types of things could be used. We're going to look at an order for paintings. So an artist wants to sell her paintings, and we're selling 2 different types. We're selling matte paintings and glossy paintings. We're going to set up a table here. This is kind of optional for these problems. This could actually be used for the problems that we've done before, but not necessary. So I'm going to write optional. You could figure this out without setting up this table. What I'm going to do is just kind of create an array here. So I have a couple different things going on. They told me the number of matte that are sold. They told me the number of glossy that are sold. And then we also know the total that was spent on each order. So I'm going to call this the first set, so set 1, and this set 2. So for set 1, we had 45 mats sold, so I'm going to call that 45M. We had 30 glossy sold, so 30G, and the amount made from the mat and the amount made from the glossy had to add up to that total of 465. And then we have something very similar for the second set, except I have 15 mat, I have 10 glossy, and the total for that is 155. So we're going to take that information that I have in that table and translate that to equations now. So that's going to be my second step. So write the system of equations. Okay. Okay, so we're going to take that array, that table I have, and take it and now write the system of equations that corresponds to it. Okay, so if I look at that, I'm just going to translate it to 45M plus 30G equals 465. That was for my first set. And then my second set was 15M plus 10G equals 155. Okay, so now I just have a system of equations in standard form. I'm going to solve by elimination. Okay, so you might be noticing that I need to multiply one of these equations to get my variables to cancel. I'm going to go ahead and multiply the bottom one by 3. So my attempt here is I'm going to try to cancel those g values. I have 10g on the bottom equation, 30g on the top. If I go ahead and I multiply this bottom equation here by 3, then I know that I'm going to have a 30g that could cancel with my top. So when I do that, I'm just going to copy the top one down again. 45m plus 30g equals 465. When I multiply my bottom one, I'm actually going to get 45m plus 30g equals 155 times 3 is 465. So if I go ahead and subtract those, you might be seeing that I'm going to get 0 on this side. I'm going to get 0 on this side. So the information that is provided to me, I can't find what M and G are. I can't find the price of these things. So because this 0 equals 0 is true, from the information I have set up, I have infinitely many solutions. Now we know that's not the case. There can be an infinite number of prices for these things, so we're just going to say not enough info provided to solve. Because that's the context of this real-world problem, we know that there's only going to be one price for each of those types of things. Okay, so let me just wrap this up, guys. The only thing that we need to look at is the summary. This is on the bottom of your notes. I just want to point out that we have one solution when our lines are different slopes. We have no solution when my lines have the same slope, but they have different y-intercepts. That's the key here. But then if we have the same slope and we have the same y-intercept, then they are the same line. So in this case, I have 0 solutions. Oh, I'm sorry, I have one solution in this case. I have 0 solutions in this case, and I have infinitely many solutions in the last case. Okay, what I'd like you guys to do for the rest of the time, finish up those notes. So if you didn't complete those problems as we went through that I left blank, go ahead and do that now. If you go on Canvas under quizzes, there's something that'll say 5B checkpoint. There's going to be a couple problems on there, about 6 problems. I want you guys just to do those over and over and over until you have them all complete, just to give me an idea of where we're at with this. And then the homework is from the Digi website, Digi5B 2 through 13. Now the first part tells you to use a graphing utility. You can either use your graphing calculator or Desmos to do those. And the rest you can do by hand. Have a good rest of your day, and I'll see you guys tomorrow.